we're going to talk a little bit about logarithmic applications. Now, there's lots of different places where logarithms get applied, but Hawks has chosen 3 different scientific applications that we're going to talk about. Now, the first is going to be the Richter scale. So the Richter scale basically says that the value on the Richter scale is equal to the logarithm, base 10 logarithm, of the intensity of the earthquake divided by what we consider like a base level intensity, like of they call it a level 0 earthquake. So what they give to you in the problem, though, is kind of weird. It says, well, what if you have a earthquake that is 80 million times as intense as a level 0 earthquake? Well, what would that give you? Okay, well, that's not that's not the intensity, and that's not the base level intensity. But what it is, it's the ratio of the intensity. If we say it's 80,000 times more, then that's the ratio. So basically what they've given us here is this ratio here. So instead of giving us this, they went ahead and gave us the ratio. So we can plug this right in. Log 80 million. Now, let me stop right here and say you can plug that right in. It's going to give you an answer right away. But I want to point something out. One of the advantages to using base 10 logarithms is if this guy right here, this is 8 times 10 to the 7. Before I've done anything, I can say this. And what is log base 10 to the 7? Well, that's 7. Okay. And this is going to be something slightly less than 1. Okay. So this is going to get me something around, 8. Okay. Well, let's plug it in, find out. Log of 8 is 0.903. So we wind up with 7.903, which is the same exact thing you would have gotten had you just plugged it in from the start. So this is going to be a 7.903 on the Richter scale. Again, the only reason I showed you this is I wanted you to understand that you can get pretty close to the actual value without actually putting it in because of the way that scientific notation works. All right, the other 2 applications. So we've got decibels, which is a measure of loudness, okay? So the number of decibels is equal to 10 times the base 10 logarithm of the intensity of the sound divided by some base level intensity, okay? This base level intensity, they go ahead and give you the value of. It's 10 to the negative 12. And it wants to know, okay, if the number of decibels is 156, then what is this intensity? So I plug this in. I also plug in this value that they gave me. All right, so this is 15.6. I'm dividing by 10. And I'm going to go ahead and do this. Oh, sorry, not negative 12, 10 to the negative 12. What is log of 10 to the negative 12? Well, that's negative 12. So minus negative 12. So we're going to subtract 12 from each side. So I get 3.6 equals log I. So this kind of feels like we're stuck. Well, we're not. If you get stuck in logarithmic form, you should change to exponential form. If you get stuck in exponential form, you should change to logarithmic. So if I'm stuck in logarithmic form, I'm going to change this to 10 to the 3.6 equals I, which is equals 3981 plus some change, okay? But this is going to be the intensity of that sound that is producing 156 decibels. All right, finally, let's look at pH. So pH is a measure of whether something's an acid or a base. So it basically measures acidity. The formula it gives you is pH equals negative log 10, log base 10, and then it's the concentration of, I think it was hydronium. I'm probably saying that wrong. But this particular ion in your solution. So it's asking, hey, what is the pH if this is my concentration of hydronium? So I'm just going to plug it in. Negative log 5.6 times 10 to the negative 12. Again, you could just shove that right in. Just to practice what we've been learning though, I'm going to go ahead and do this plus log 10 to the negative 12. So this is negative log 5 plus 12. Okay, so 12 minus log 5 is 11.30. Again, you'll see this is basically just a rounding error. It's only a little bit different, which is why I'm showing you this, because you should be able to look at this and go, oh, it's going to be about 12 without even needing a calculator. So that's our pH. So these are some different applications of logarithms. Just plug them in the formula, see what you come up with.